Okay, here we are, 9/4. This is getting ready for Thursday or Friday when I'm not here. We are trying to graph cubic equations. Now, your standard cubic equation in its simplest form is written like that, and that's going to produce a graph that goes typically like this. All right, so it's going to be up on the right and down on the left. We call that right-hand behavior and left-hand behavior. If I put a negative in front of this, though, it'll do the exact opposite. It'll make it go down on the right. So the right-hand behavior is going down towards negative infinity, and the left hand is going up. So you get to look at these and see if there are any negatives out in front of the parentheses. If they're not, then you multiply those all together sort of in your head, and you get a positive x cubed out there. We're going to leave this in factored form for graphing because that's really the easy way to graph. What we're going to do is we're just going to draw our axes, and we are going to plot the zeros. Well, the zero is just when this is equal to 0. The 0 for this parentheses is positive 3, so I'm going to make a point there for that 0. The 0 for this one is when x is negative 2 plus a positive 2 gives me 0. And this 0 is when x is a positive 7, so 4, 5, and then 6, 7. There's my other 0. And we know that it always goes up on the right if that's not negative, if it's positive. So it's going to go up on the right like this. On the left, it's going to go down. So when this graph does its swoop, it's going to go through there at 3, and then turn the corner and go up. Okay, we're not so concerned about exactly the shape of this. If I want to find this point right here, I can plug in a 0 for the x. That's different than when these are equal to 0 in the parentheses. If I plug in a 0, that's negative 3, times a 2, that's negative 6, times when I plug in 0, negative 7, that would be a positive 42. So I'd have to give that 10, 20, 30, and there would be 0, comma 42. But we're not doing that. We don't have to worry about it so much, but you could find those points if you wanted to. We're really only interested in getting the general shape and plotting those zeros correctly. Okay? So, if we go to this second one here, this is one of the wrinkles, and you guys know what squaring means. It means multiplying something by itself. So I really just have 2 of these here. So I could write it like this, x minus 2, and I can put these in any order I want to, so that's not a big deal. But when I go to graph it, what happens is I go to positive 2, because that's my 0. I then go to negative 3, and that's my other 0. But then here I am at positive 2 again. So I sometimes, just to emphasize that, I'll draw a circle around it, and that's like a double 0. And I call that bouncing. And that's like you go to the right-hand dot, and it's still going up on the right, okay? Because our right-hand behavior is that it goes up, and that's the last point that we know of on that axis. The left-hand behavior is that it goes down. But there's no point in the middle, so do not do something like this, because there's no 0 there. There is only a 0 right here. So what is happening is that this is the bounce. So it goes up like this, and then it bounces right there. It touches in exactly one point, like a point of tangency, as if the graph were like resting on the floor and just touching in one place. And I have now a graph with this curve going like this, and it just happens that the axis is right on the lowest point there. So if you think about it, if I had had the square here, how would that have changed this graph? All right, so now if I do that in blue, I'll make that in blue just for emphasis, it would now be that the bounce is here at negative 3. So it would still go up on the right like this, it would still go down on the left like that, but it would come below and then bounce right there and go down. So that's the way it would change. All right. So you'll see in the book on page 532, there's a lot of problems, and I'll be posting that homework for you guys to do. You're basically just graphing like that. Good luck.